Hello all, this is my homework for Paul McWhorter's AI for Everyone using Python lessons. This is the homework for lesson 14 using the OpenCV libraries. So I've really documented this fairly extensively, so you can see most of this homework is based on the examples given by Paul in his YouTube lesson 14, and so I've used most of the things directly from the lesson, other than the final aspects of the homework. Paul wanted us to do something with the data that was returned from the object of interest. So as we go through this, it's fairly straightforward. I imported time because I use that doing some diagnostic things. I could probably remove it, but I'll just leave it there for now. Set up variables for passing and collecting the data. Hue high and low, hue low and high 2, sat, and I set those at some default values to begin with. We define the functions that create the track bars. In this case, we used 8 of them. We had, from an earlier lesson, we had hue high and hue high 2, hue low and hue low 2, and then we just used the saturation and value for both objects. We were tracking 2 objects. You can see my lesson 13 homework if you'd like to do that. So we define the track bars. Now, as part of defining the functions called on tracker 1, 2, 3, etc., we did use the print command just to show the value of the sliders was working, but I've commented all that print statements out. So the next step is to define variables, setting the display size, and for me, just to keep it with the same 9 to 16 ratio, 16 to 9, I just set the width to divisible by 2. We create a window to display our trackers. We resize it and we move it. In my case, I moved it to the far right of the frame from its original position, and then resized it to be large enough to have full-size trackers. I create the track bars, and you have to do this in the order you want them to display in my tracker. So again, my note says we only create hue high and hue low for the 2 objects, then we use the same sat low and sat high for the objects. We set up the video capture using Paul's template. You can find that on Top Tech Boy. In fact, I give you lesson 6 is the number faster launch of webcam and smoother video in OpenCV. Oh, gotta back that out. I didn't want a one while true, I wanted a while true. Got carried away on the keyboard over here. As long as we haven't broken, we grab a frame and show a frame. We also create upper and lower bound arrays, because when we call the contour, it's going to want the values. We got to ask it, is it in the range of the upper and lower bounds that we've already set? So for my mask and my mask 2, we call the inRange function to see if it's even within the upper and lower bounds of our color values for the object we put in. I forgot to mention up here that, and you'll see this in the lesson, we want to convert our color, get and define the variable frame HSV is equal to the frame cv2.color.bgr to HSV, which is the conversion from blue, green, red to HSV. Okay, now we have our two masks, and you'll see in the display, one is a color mask, a black mask showing the object in color. The other is a second mask showing the object in black and white. Well, I want to track on them, so I'm saying that my mask is the OR of, which converts my mask, or gives you the data from my mask to combine with my mask as the white or ORed object. So this is the part of the lesson where we focus on finding the contours. It returns two values, the contours and stuff. We pass it my mask and tell it we want to have a retrieval of the external rather than a fill. So we want the data around the shape, and then we tell it we only want an approximate simple rather than printing or calling up every pixel that might be invalid or might be valid. We just want a simple approximation. In the lesson we did draw the exact outline of the object, but we didn't want to do that for this. We want to make sure the contour is in the contours, and we set a size limit. If it's bigger than this, then all we want is the contour. First we drew it in blue, that's part of the lesson, but then we decided we would do a rectangle, and when we called the rectangle, we set it up for to draw the frame at the X and Y plus the, or draw it on the frame using the X and Y values plus the X plus width and the X plus height. We set it to 0, 0, 255, which is red, and we set an outline width of 2. I needed to tell it how far it could go before it was off my monitor, so I just said if X is greater than or equal to 0, then the and if the X plus the W, which is the width, is under 1920, and if X or if Y is greater than 0, which is the top, and if the integer Y plus H would be the bottom frame, is less than my screen resolution is 1080, then I moved it. Moved the window, my webcam, to follow the object of interest. The aspect ratio of my webcam frame to my monitor size is approximately 1 to 1.6, so I used those multipliers in setting the X value for the XY values for the location of my webcam frame. I display using the My Mask and My Selection. I wanted to show those, and I resized them, and I set them to show at the 0, 0, and then the 0 and half the width. Pardon me, at the bottom was set at height. The top of the two frames was set at height. The first one was set at 0, and the second one is set at I'm sorry, they're set at the frame height plus 30 because I didn't want them behind. Anyway, you can follow this. We'll see it when I display it. So I show the webcam, which is sized at width and height. I did not set the location to 0, 0 every time we went through, so I wanted it to follow the object of interest. We exit by braking when Q is chosen. We finalize by destroying all windows and print that the windows are destroyed so we know we're done. Then we give the camera back to other programs. So I'm going to go ahead and run this now. You can see my frame. You can see my two masks, my mask small and my mask selection. I will bring this in way over here so you can see as it appears. You can see I have a color mask showing it and an ORD white mask. And so this is the frame following the object, and it stops at the edges. So I'm going to see if I can get this back up, and I will leave a copy of my code. I'll leave a link to a Google Doc where you can get it, and you will also be able to run this because it'll be formatted for Python. I will also show in the description a link to Paul's video, and then I will leave a comment on Paul's video showing how I am Legend. Have a great day.